This is activity 4 in lab number 5, and the problem that I will be doing is something from a previous test, and you're asked to take a look at this geometry. First of all, use the most appropriate element, and obviously you're not going to use beam elements here. Solid element is what we're going to be using, although if you had shell option, I mean, we have not discussed shell. Shell is also can be considered to be a good element for this problem, but we haven't done shells yet. This has to be done with solid elements. Okay. Now, use as many planes of symmetry. Now, notice that here the inside holes are both fixed, and at these two faces, I'm applying a pressure as shown. Now, this being the case, so the geometry is symmetric, the loading is symmetric, and the restraints are appropriately put so that they're symmetric. Therefore, there is one plane of symmetry in the vertical direction, one in the horizontal direction, and one through the thickness. So the bottom line is that all you need to do is to model 1/8 of this object and then do your problem like that. Now, it's entirely up to you whether you can create the whole model and start cutting it so that you get 1/8 of it back, or you can start with 1/8 of the model to begin with. Now, the other thing is that it says make sure that you have local mesh refinement around the hole, so don't forget to do that. All right, so I'm going to actually make 1/8 of that. How about that? So let's go here. Let's start with the Catia or part file, and immediately I'm going to save it. This is a prelude to what's going to be coming on the test. As far as the saving and things like that is concerned, save management, save as. I have a folder here which is called activity 4. I'm going to put it in there. All right, on a convenient plane, on that vertical plane, I will sketch. Notice, by the way, I'm in wireframe and surface design, so eventually I'm going to switch to part design because you cannot pad stuff in wireframe and surface design, okay? So we'll do that later. Now let's go ahead and make 1/8 of this somehow dimensions. I'm going to do in a minute. So basically it's like that. Uh, sure. Um, let me see what's the best way of doing this thing. Should I use this? Nah, that's not a good idea. That's not a good idea. Okay, so let me get rid of that and do the rest of it. So why don't I actually go ahead and create a circle up there, or maybe, okay. And then let's see now, we go down here. Yep, okay, so go like that. We will fill it up like so, and like so. Okay, first of all, I want this to be tangent to that. This angle to be 100. Why don't I do these dimensions first? Let's see before. See now, these dimensions, there is 3 inches this way and 1 inch up. So let's clean that up. So this is 3, and this is 1. Okay, what else do we know? Why don't we make this tangent to that? So this could, actually that radius, yeah, that radius, we can make it 1 inch. Yeah, 1 inch. Let's change this into 1. Good. And now we make this angle 120 degrees between this and that line. 120 degrees. Okay, what else do we know here? Uh, oh, this is 1 inch. So let's go ahead and do this. That is 1 inch. Okay, and now we're going to make that curve tangent to this. Okay, so let's see. how this can be done. So this curve, not dimension. Okay. Oops. Like put this thing back to 1. Very good. So now I want this curve, this white curve, this was circle, and that to be tangent to each other. Let's see if we can make it. This one and control that. Can we make a tangent? Tangent. Yep, we did it. Okay, so what you see here is actually this piece, except for that circle that I have to draw. So that circle, yep, let's do that circle. Do a full, well, you can do quarter circle. That's fine. So you go from here to here. The radius of that is 0.5, I believe. So let's make that thing 0.5. That is 0.5, very good. And do a cleanup. Cleanup, my favorite way of doing it is with the quick trim, which is this eraser under operations, this eraser. So I want to get rid of this. Yep, that's good. Oh yeah, I forgot to do a fillet here. There is a fillet of radius. Is that a fillet? No, I thought there was a fillet. That's okay. We don't have a fillet. Fine. That's okay. So exit, pad it by half an inch because remember we are doing a 1/8 of the model. Now we don't have pad here because this is wireframe and surface design. So we switch to part design, and that's where I see the pad right there. 0.5. Yep. So this is 1/8 of the model. It's made out of steel with default material properties. So click on it. Metal, steel on that part. Very good. That's pretty much it. So now we're going to go to analysis and simulation, generative structure analysis. It's a static problem that we're doing. If you want to look at the mesh, you can do that. That's fine, right there. However, we are told that I want a local mesh around this hole, and I want to make sure that you guys know how to do it. What the size of it is totally irrelevant in our course, in my course, on a test. See here, just use the default value, whatever it was from last time. So now if you say, show me the mesh, you see that unless I tell you what value you should be using, just do whatever you want. You can see that defined in this area, cursor in the rest. Deactivate. Now, surface slider, because we have planes of symmetry. So for example, the back, the bottom, this side, and that top piece, that top face. Okay, these are all planes of symmetry. You say surface slider, and on this piece, on this back face, on this face, we put a pressure of uh, half of what's given, or 1/4 of what's given. So 200 divided by 5 is going to, divided by 4 is going to be 50 pounds. Hell no. If you do that, you lose points, big points. So if you do that, you lose 3 points, okay, out of 20 marks. Because pressure, you don't divide by 4 because you just took 1/4 of the surface. Okay. Load you will. If this was 200 pounds, then on that quarter of a geometry that you of that face, you put a quarter of the 200 pound. But this is pressure. You don't do that. Do not divide by 4. Okay, so let's go ahead. Let's go ahead and put a pressure there. There's the pressure on there. And because it's tensile minus, what was that, 200? Yeah, minus 200. It's a very simple problem. Nothing fancy. So now we're going to run it. Don't worry about this warning message. Remember, it's talking about rotation constraints are not uh, degrees of freedom for 3D elements. We know that, okay? So just go ahead and let it run. Let's save the analysis file, save management. Analysis is there. Analysis, save as, or up one level, activity 4. Make sure you don't put it in the wrong place so that it overrides the other guy, and I don't have a way of marking you for the other problem. Put it in the right spot. That's pretty much it. So if you look at the deflection, it is what you expect, right? It is what you expect. If you want numbers, there we are. Needless to say that when you put a pressure here, it's going to elongate. You can see that. And if you want Mesa stress, the biggest stress is in this area, but if there's a fillet here, it's going to be reduced. These are very low stresses anyway. So that's pretty much it. I'll take care of activity number 4. And there's one more to do, activity number 5.